My name is Bashar Ifai. I'm a partner solution architect, database specialist. Today, we're going to be talking about the Rdstools. This is a quick video that we're going to talk about the Rdstools capabilities and what it does. There will be more deep dive videos coming up about each function of the Rdstools and how to use the Rdstools. Rdstools has two main pieces with few additions. The very first one is the RDS discovery. The second one is the SQL Server assessment. The RDS discovery is a quick scan on the RDS limitation. It runs across all your fleet of servers and highlight the features that they may be blockers to move to RDS. On top of that, it will give you a quick assessment on the queries in cache and look at those queries in terms of read versus write. And if read versus write is well over the 70%, then it will suggest that it could be potentially a good candidate for Elastic Cache. Again, this is a quick assessment. It's a great for a conversation starter, for pre-sales, to get the, to understand what the scope looks like and to have a good understanding of what you're looking at when it comes to the SQL servers. The second piece is the SQL Server assessment. This is a more of a collection job that runs on all your servers as a job. You can set up the jobs to run several minutes. It could be 1 minute, up to 1 week, 2 weeks, 3 weeks is really up to you. It's up to the customers. They know their workloads and they know how long it should take. But we will recommend usually a minimum of 1 week to just capture all the different workloads across all different servers. The collection is it collects memory, CPUs, IOPS, and throughputs, and it does a right sizing based on those four metrics. So all those four metrics are needed to give the right sizing for your workload. On top of that, it will do a deep dive elastic cache assessment on that workload. We look at the read versus write on every minute. And if those reads are more than 70 to 80% than the write, then it's a good candidate for elastic cache. And we highlight that in the output reports at the end. You will get reports based on the server level and on the DB level as well. So you will get the DB level for IOPS, memories, and CPUs. On top of that, there will be the total cost of ownership. This is an Excel sheet that each of those tools will write to this total cost of ownership, which eventually will tell you what's your cost of the server is going to look like in RDS. Typically, when before the tool, when we used to look into migrations, there will be this template that will go and collect the information, versions, additions, and all different features that you see on your right side. That is actually, those are the potential blockers for RDS. That was manual, and the RDS discovery came in to just to automate that piece. So the RDS discovery, I said, it will automate that piece. It will highlight all those features and it will show them in yes or no whether it been detected on your workloads or not. One thing I want to add is do not take this as the final answer, right? So deep dive with your customers on each of those issues because there will be multiple places where customers have created CLR, for example, for a specific workload or for a specific time and they no longer need it. And when you really have a good conversation with the customers, most of the time they tell you no, we don't need it and we can actually move to RDS without CLR. Linked server is another example. You could probably see a linked server for Postgres, which is a limitation. But when you really look into with the customers and whether this is needed or not, most of the time you're gonna find out that this is actually not needed, and you can move on without the linked server to Postgres. The output will look like this. It's an Excel sheet and HTML. The Excel sheet will have more details. The server name, the few questions that get asked in the template, the edition, the version, and then the rest of the features that is highlighted in yes or no. Yes being it has been detected, no is not detected, and it will tell you whether it's RDS compatible or RDS custom, EC2. It gives you the enterprise level features, and this could be used to determine whether your edition could be scaled down from enterprise to standard based on whether you're using editions or whether those editions became standard on future editions or future version of SQL Server. You'll get the memory CPUs, and the tool has the ability to give you RDS instance based on those memories and CPUs. This is as I said, it's quick scan, takes few minutes based on how many servers you have, but it gets you the information quickly, so you can just start working on the opportunities a lot quicker. The SQL Server assessment is more deep dive, is more detailed assessment. It runs on your SQL Server. It creates an agent job and few tables in the MSDB. The few tables will have per minute collections on the memories, the CPUs, IOPS, and throughputs. Those are collected per database level, and they are collected from within the SQL Server, not from the server itself. So we collecting database metrics and server metrics, not a SQL Server metrics, not the server metrics. The reason for that is we want to minimize the extra noises that could be happening on your server, because we only care about those databases because those are the one that's moving to AWS. So that's the reason it runs from within SQL Server. We don't touch the perf mount. Uh, it collects every minute. It sits in MSDB, and by default, it runs on top of RDS Discovery. And that's very important piece because if RDS Discovery, for example, highlight that one of your instance is not an RDS, it could be RDS custom. Your instance sizing will be RDS custom. It won't be RDS. So pay attention to that. It's very important piece of information. If you want to bypass that, you can just mention or you can just put in into your command that I want to use this servers rather than the RDS discovery, and it will run on your list of servers or your input. But if you do not enter server names in your command, it will pick up the RDS discovery and will run against that. The tool has capability to run as an agent or agentless. Agent, we just discussed it. This is the one that creates a job and collects information and put it into the tables in the MSDB. Agentless is, for example, when you have limitations or you have some security restrictions, you cannot run agent, you cannot create tables. There is a query that comes with the tool. You can load that query into Query Analyzer. You can run it 1, 2 minutes, 3 minutes, is really up to you, and it will create an output. That output could be saved as CSV, moved to the tool, and your tool will run offline and will give you the recommended the right sizing for your instance and your workload. Uh, you can use that. You can use SSMS or you can use Task Manager to schedule the queries. It's really up to you as long as the information that we receive back is something that is recognized by the tool and in specific order. Or you can use your third-party tool to generate those metrics, as long as I said they are in specific orders, and this order is well documented into the GitHub of the in the tool. And we'll share the GitHub location later and later slides. The SSAT output, you have the two main sections, which is the CPU and the memory. The CPU will get three different metrics of the CPUs. The CPU utilization, which is based on 80%, the 95 percentile, and the CPU utilization, which is the average. The CPU pressure, which is, as I said, the 80%, it actually look at any data point that's over 80. And this is a little bit more aggressive than the CPU 95 percentile. Most of the time, if you have most of your collection point less than 80, you're gonna see this as zeros. You might see 2, 3, 10% in 95 percentile, but it may always be zero just because not a single selection collection point was over 80%. The memory, we look at two metrics. We look at the max SQL Server memory and the PLE. The PLE is collected across all NUMA nodes, and if those two numbers are well over the 80%, we collect overall, and then we make a decision whether it's a memory pressure or not. So how do we scale up or scale down? This metrics will probably summarize the scaling up and scale down. If, for example, the memory utilization was over 80 and CPU utilization was less than 80, we do not scale you up, but we'll move you to memory optimized instance. What that means is we have two different offering of instances for RDS. And specific for SQL Server, we have the general purpose, which has 1 to 4 ratio CPU to memory, and the memory optimized, which has 1 to 8, and they could go up to 1 to 30 and 1 to 15. And those are the memory optimized. So if your memory is over 80%, but the CPU is not showing any pressure, we do not scale you up. We try to save you money on licensing, and we'll put you in the memory optimized so you can take advantage of extra memory. If both metrics are well over the 80, we will scale you up and we'll put you in memory optimized. If the memory is less than 80 and CPU over 80, we'll just scale you up and leave you on general purpose, so we'll just save a little bit more money. If the memory is less than 50 and CPU less than 50, we basically just scale you down. If memory and CPU over than 50 and memory and CPU less than 80, then just no action happens. And if you see in the screenshots here, there's a two example of a scale down for CPUs, but memory is showing pressure, so we can scale you up. And basically here we move you from M5 12x large to R5 12x large. The M5 being the general purpose, the R5 being the memory. So it's still 12x large, still the same CPUs, still the same license, but it's a memory purpose, and you get 8, uh, double the memory just because of the 8. The ratio is 1 to 8. The second example here, we scale you down on both CPUs and memory. So you go down from M5 12x large to M6 8x large, or M5D or M5. So you stay in general purpose, but we scale you down. IOPS and throughput, those are the other two metrics that we collect, and very important two metrics. All four metrics is the memory, the CPUs, the IOPS, and throughputs. They determine the instance of your EC2 or the RDS instance. Each EC2 has a limitation on how much IOPS and throughputs it can support. So those two metrics are very important, and we collect those, and we'll make use of all those when we do the right sizing. There could be uh, instances where your CPU recommendation or the memory showing that it needs to be scaled down, but due to the IOPS, you will end up being scaled up just because you need higher IOPS that's supported by higher instances. So just pay attention to that. If you notice this and you notice that you are scaled up, but your recommendation say scale down, that could probably be because of the throughputs or and IOPS as well. Agentless, as I said, there's you can run the queries. The query can be found in Rdstools/n, and it's called SQL Server Manual Collection. It collects exactly the same information that you can find in the automated tool. It will generate this output in here. That output could be saved as CSV and uploaded to the tool. You place it in the upload directory, and you rerun the tool with an option upload, and we will see those in the more of a deep dive videos that's going to come up after this video. As long as the order is exactly the same, the tool will pick up this information, will do analysis, and will give you the right instance. If you have a third-party tool, you can definitely create CSV exactly like this one. You don't have to worry about the compute can be scaled down or the memory can be scaled, as long as we have the utilization and the memory utilization, throughputs, and total IOPS in this order. The tool will pick it up, they will understand it, and will be able to give you right instance for that workload. So what is the CPU? Let's just look at the CPUs closer here. As I said, the CPU pressure, the CPU 95 percentile, and the total utilization. The total utilization is an average. This is not something that we really use into our calculation, but I just left it there just for awareness to see how what's the difference between your utilization and the 95 percentile and the 80 percentile. As I said, we collect the SQL Server specific usage. And this table will show the SQL Server specific CPU utilization versus the other processes on your server and the system idle. Uh, the 80 percentile, as I said, will check any collection point that's over 80, In this example, none of those collection over 80, so it's going to show 0. The 95 percentile is going to look at this and is going to multiply it, is going to order by the CPUs, multiply by 0.95, and the 13 is going to be your percentile, 95 percentile. So here the 95 percentile will probably be 13. So that's the difference between the 80% and the 95 percentile. Sometimes you're going to see this is always 0, the pressure, just because there's always the numbers are well below the 80%. The memory metrics, we have multiple information that is in the memory. You have the SQL current memory usage, which shows the current memory usage in the buffer pool, and that's measured against the max memory set on the instance. So we capture the instance memory, not the total server memory. And that's because we want to make sure that we are capturing that. That's in case there's a multiple servers on that, multiple instances on the server, we only capture the instance. So this is the one that we worry about, those two columns. This is the your setting, the max setting on that instance. This is how much you're using toward that max. And the PLE. The PLE is a page life expectancy, which basically what it tells us is how long the page is sitting in the buffer pool. The quicker that page is getting kicked out of buffer pool, the more memory issues that you have. And there's a bit of calculation that happens to determine what is that number is. And I have some documentation on the end of the slides that you can go ahead and take a look and see how I'm using that. But it's basically I am using I'm using the 300 milliseconds per each 4 gig. And that is collected across all different numas. So it's multiple numas. We collect that across all different numas. The output is, as I said, it looks like this. You get the scale down, the scale up, overload is acceptable, the IOPS and throughputs and all that, and you get the HTML summary as well, which is basically summarize all the information. That's something you can use and send it to executives, your managers, your CEO, CDO, and tell them, okay, here's what it looks like, here's the information, and just be able to use that. So the elastic cache assessment, as discussed earlier, is it's in the two tools. The RDS discovery is just a quick assessment. It assesses the read versus write of those cached queries. The SSAT, the SQL Server Assessment, looks at the each collected metrics from the DBIO and calculate that and look at the read versus write. If the read versus write is over 80%, then that's a clear example of elastic cache, or there could be potential good candidate for elastic cache. And it looks at it from the server level and it gives you the database level. So let's say it possibly that you as a server level, you might not be a good candidate, but maybe one of your database is good candidate for elastic cache. So they give you those breakdowns as well. TCO. The TCO is your total cost of ownership. Uh, it's an Excel sheet that sits in your in directory. Uh, it gives you the cost comparison between EC2 and RDS, and as well the database infrastructure cost, including the compute, storage, backup, transfer, and data transfer. Additional costs for self-managing database on EC2, for example, the staff productivity, saving hours, all that. So it capture all that and calculate that into the cost. Uh, the way the TCO works, when you run the Artist discovery, it will create the entry in the TCO and populate the actual instance based on the configuration, not based on the right sizing. The SQL assessment will come in and will update that record with the actual utilization. So there's two passes into this. There is the very first time where you get the actual configuration creation, and plus the second one, which is the right sizing. It's an internal tool, but this is something that we will share with partners, but it's not something that we will share with customers. And if you would like us, I mean, if you can send us the workload, we can definitely run this for you and share the TCO from our end as well. This is what the TCO look like, especially with the EC2 versus RDS comparison. The RDS tool performance impact, this is something will come up all the time. The very first question is what's the impact on production? Everybody's worried about the production, rightfully worried about the production. The tool itself is the actual answer to this question. If you take the tool and run it on any environment with minimum or no activities, you're going to see that it's going to capture zeros, just like this one here. I run it on one of my SQL server, have multiple databases. There's absolutely no activities. As you see, there is zeros here. There's no activities when it comes to the CPU. The IOPS and throughputs, they were showing zeros as well. So absolutely no activities across. There was like 20 minutes that I ran this, or 19 minutes. So the tool itself is the answer. You can go ahead and run it in development, get the feel of it, see how it works, understand what it is, and get comfortable, and then move it to production. But the tool has absolutely no impact on your production. Those are the references that I've used, some of the information that I used. You can find the tool on GitHub. This is the website where you can find the information, where you can find the slides, and that video will sit on that uh, website as well. The website is hello. It has a lot of information that you can probably find it useful. And the rest is just the information, some blogs, and some information that you can use on what's the page life expectancy, how you utilize that, why I'm using the metrics that I'm using for CPUs, for apps, for throughputs, and so on and so forth. With that, that will be the end of these videos. We'll see you on future videos of the deep dive of RDS tools. Thank you so much.